Hi everyone and welcome to my video. Hope you enjoyed that intro music there. But what we're going to discuss right now is the difference between AC and DC. These are the two ways in which electrical power or current is transported. AC stands for alternating current, while DC stands for direct current. These names are pretty self-explanatory with how they work, but we'll still briefly go over them right now. But why isn't current simply transported the same way for everything? Well, it starts all the way back here at the power plant. Whichever mechanism that generates the electricity, whether it be solar, wind, hydroelectric, for example, it sends out the current in its AC form. The overall voltage when leaving the plant is so powerful that it would completely overwhelm any standard household grid, for example. For this reason, transformers are used to bring the voltage down to a more manageable level. Now this matters because it is possible to transform the voltage in a DC form, but it's just easier and cheaper overall to do this while it's in its AC form. Once it reaches the house here for use, the current must usually then be converted back into DC to use in most electronics like your video game console, TV, anything like that. So hopefully this gives you a basic overview, but we'll get a little more into it right now. And now I really like this diagram here, which is a great visual representation of how the two types of current work. We've got voltage here as a function of time. We've got this red line here, which stands for direct current, and this blue line here, which of course stands for alternating current. Remember that current is defined as the flow of electric charge from a high potential to a low potential. So I just wanted to introduce this diagram to you. We'll come back to it in just a minute. Keep it in your mind for now, but we'll go ahead and move on. So we'll start off with alternating current. Alternating current is the flow of electric charge that periodically reverses direction as the polarity of the voltage changes. What's essentially happening here, as you can see with this little GIF here, is that the charges flowing through the circuit are moving back and forth depending on the potential difference at that point in time. Alternating current is used because it's really easy to change voltages. It's more efficient to send these high voltages over long distances, but this does of course make the generation process less portable, which is why we have such big power plants and things of that nature. Something interesting about appliances that use alternating current is that if you think back to that graph, there's that point where it passes through the zero line on the voltage. I'll point this out again later. But this causes essentially a slight interruption as the potential is switching back and forth. So think of like a flickering light bulb. This is essentially a slowed down version of what happens through most appliances that use this AC format. It's happening all the time, but our eyes just can't perceive it. And like I mentioned before, this type of current often requires the use of transformers to make the electricity received usable. When it passes towards the household for use, it goes from a high number of coils in the transformer to a low number of coils to decrease that voltage and make it usable. As far as uses, again, power distribution, any sort of electricity that is used in your house, office, any building is received in this AC format. Now we have direct current, which is the flow of electric charge in only one direction. We've got another handy GIF here, and you can see how the current is flowing in a loop. It's going from an area of high voltage potential all the way around to low voltage potential. And when it gets to this lower region, it's usually pumped back up with the use of like a battery, some sort of electrical or chemical process to pump it back up to high voltage potential and again pass it through. Therefore, it is of course a constant supply of power, and it makes it much harder and more expensive to change the voltages of direct current, which is why power isn't distributed in this form. As far as real-world applications, oftentimes direct current actually connects AC grids to each other, but more commonly it's used in your electronics, so that the current is flowing through it linearly. When you think of the anatomy of your devices, there's of course little components that the current must flow through in order to make the thing work. If we were to use a alternating current flowing back and forth, it would just make those components in the device overall just go haywire. So to avoid that, if you think of most of your devices that have a power cord, it usually has a little box that's part of that cord. And what this does is it converts the current from the alternating current format into the direct current form for use. So there you have it. We're back here at this graph, and to briefly summarize, we've got current, which is the flow of electric charge from a high potential to a low potential. We have direct current, this straight line across, constant voltage, constant flow in one direction from high potential to low potential. We've got alternating current, has this wave type function, flow of electric charge that periodically reverses. If you are curious, alternating current typically runs at about 50 to 60 hertz or cycles per second. When it passes through the zero line here, at that moment in time, no electrical power is being supplied to that device, and so it does have a slight flickering effect. And there you have it, the difference between alternating current and direct current. Hope you enjoyed the video, and I hope you learned something new. Thanks.